Hey there, everybody, welcome back.
This is the support course, Quinn, of course. I gotta do an intro for the video watchers, of course. Today we're gonna start looking at the average of numbers. Or mean. So if we wanna find the average. Yeah, too much. Maybe I'll lower this. Find the average. Set of numbers. One, we're gonna add up all the numbers. Two. We are going to divide that total or sum. By the amount of numbers there were. We usually call that amount n. It's gonna be in the letter n, and it's definitely a lowercase n. And we will talk about this again in the main class on next Tuesday. Or is it Tuesday? It might be Thursday. But getting you guys started on the numbers now is a good choice. So let's say we have, I don't know. $39.22. And we got $71.81 and maybe $5.97. So step one, we will add these all up. I got smart today. I figured out I actually don't need these lights on. And the room is bright enough, and it makes it so the calculator stands out pretty well, which is nice. So I'll go through and add these bad boys up. And I'm getting 117 even, so there must be no change there. And then there are three numbers, so I will divide by 3. Wow. Well, I picked these numbers at random. Just pick 3 numbers. I went like, let's go for one around, 40 to 50, let's go for one higher, and let's go for one low. This was exactly $39, holy crap. Huh. Okay. So if you do this in the calculator. You can fuck this up in the calculator. Do not do this. 39.22 plus 71.81 plus 5.97 divided by 3 equals. I challenge you to do that in your calculator right now. You will not get 39. I want you to see this mistake in the making. How much is it? 107.02. Since I made these numbers up, I have no idea what it equals. I see. Did I enter something wrong? Let's see. 39.22 plus 71.81 plus 5.97 divided by 3. I'm still getting 113.
Did it on my phone, so that might be, so
Or you miskeyed a number somewhere.
that too.
Did anyone else get 113? Okay. So what's going on here? What's really the problem here is. When we do it like this, the 3 is only being divided into the 5.97. So you have two options. One is do it in 2 steps like I did. Or some calculators have a parentheses key. So if yours has a parentheses key, start her up, hit the parentheses key. Then do the 71.81 plus 5.97. Then hit end parentheses. That's telling it do all the addition before we divide. Then you can hit divide by 3, hit the equal key. And that should work. So I'll do that here. I've got parentheses keys. As you can see. Sweet spot of no glare is right there. End parentheses divided by 3 equals. So I figured get your attention with it now so that you see what the mistake is and you don't make a mistake later. Mean isn't really that challenging. Do you guys want another example or are you good? You good or you wanna? Alright, we'll go to a different topic. This is pretty easy. Most of us call it average in real life, but the word they use in statistics is mean. If you need it longer, let me know. I'll put it back. Otherwise, we're gonna do some more stuff with fractions. Let's look at. We're gonna look at multiplying fractions. This will come up in chapter 5, guaranteed. Guaranteed. If it doesn't happen any other time, it's definitely happening then. So when we multiply fractions, we multiply tops together. And bottoms together separately. Four over 7 times 13 over 6 is 4 times 13 is 52. And 7 times 6 is 42. You will see 4 times 13 a lot. In chapter 5. Does anyone know where the numbers 4 and 13 kind of? Where we have them together? or something that has 52 of. First off, might be weeks, but we don't have like 13 months, so it's not weeks. This is deck of cards. There are 4 suits with 13 ranks. And using a deck of cards is a great thing to do probability examples with, so you learn about it. It's also a great thing to get good at. If you can learn probabilities of cards, you can go in and perform better than your opposition at poker. Okay, so we also want to check for simplifying before we're done. The easier way to do that actually is to do it before you multiply. So I'm gonna rewrite that situation right there. Check for simplifying first. So 4 is 2 times 2. I'm gonna write that above it. And 6 is 2 times 3. 7 and 13 are both prime. Now I could write this as 2 times 2 times 13, and I will for now. And the idea is if you break it up before you get to this part, it's easier to see what cancels. There's a 2 on top and a 2 on bottom, we can cancel them out and replace them with ones. This leaves us with 2 times 13 on top, 7 times 3 on bottom is 26 over 21. I so had 26 in my head, and then as soon as I wrote 7 times 3, my brain went dead. I'm like, what? Huh? Rose. Now, you might be able to easily see this is divisible by 2 and do that, but sometimes like this number can be really big on top and bottom, you're like, I don't know where the fuck to start. But you'll notice if you start with smaller numbers already, these are already easy to break down. And with just a little practice of doing it, you're actually faster than grabbing a calculator. Believe it or not. So let me give you guys one to give it a try. You try. Do 8 over 27 times. Oh, I don't know. 45 over 14. Let's see, can I do this in my head? think you're gonna get 20/21. Is that what you guys got? Marcus is practicing his mental whiteboard. It's a good thing to do. The more you practice it, the better you get at it.
Yeah, I spaced out for like the blue section, so I'm like trying to figure out why you crossed the 2 and put a 1.
Oh, let me change the order of that. I can separate this into 2/2 times. 2/13. Oh wait, that's a 3 down there. Over 7 times 3. And what is 2 divided by 2? 1. So this turns into a 1. And the reason why you replace it with a 1 is if you don't put a 1 there, it's easy to forget something goes there. If you cancel out everything on one side of the fraction, I've seen Calc 3 students that know better put 0 once they canceled everything out. Because they didn't write the ones, and so it's easy to forget. So here, we go ahead and factor. 8 is 4 times 2. And 4 is 2 times 2, so we got 3 2s there. 27 is 9 times 3. 9 is 3 times 3, so we got 3 3s there. 45 is 9 and 5. So 9 is 3 times 3 times 5, and 14 is 2 times 7. And you can cancel them out without making one big fraction if you do it like that. And you get 4 times 5 on top is 20. And 3 times 7 is 21. Now, if you did this over here without breaking down all the way. You can go, oh shit, there's a 9 on top and bottom, and I don't need to go the whole way, so you don't need to factor the whole way if you see shit that cancels. But until you're like practiced at doing it. I recommend breaking it down all the way, cause it's I've seen students just miss it. They'll have a 6 on top and they'll have a 9 on bottom and not recognize they both have 3s. Cause they didn't break them down small enough, I think. Let's give you guys another one. Ready for more? Great, Bianca's still writing, and a couple others are still writing. We rushing it.
So where you're applying the 2 fractions together, like how you crossed out the 2 on the left and the 2 on the right, you can do that, like you can.
Yes. Because this is we can see that if we did what we did up here. We're gonna end up, we can put them together as one fraction,
Oh, yeah.
and so this is just like saving you from the time of putting together as one fraction.
One of my big things is I don't remember all the prime numbers.
Yeah,
So I completely didn't think about breaking down the 8.
So. Don't focus on prime numbers, think about the multiplication table. If you hopefully. And it's hard to assume this nowadays, that there's students that don't. Hopefully you have the 10 by 10 times 10 multiplication table down. They teach it in elementary school. Hopefully you know it. 8 shows up on there. Think of the numbers that show up on the multiplication table. And I'm not gonna say like the numbers that don't show up are prime, because there are more numbers that show up. Like 3 times 39 or 3 times 13 is 39. It's in one, like 10 by 10 goes up to 100. So like, but 13 is not in 10, so if you saw 39, you may go, it's prime, it's not. That only comes with more practice. For many of them, check the while you're practicing it up, check the whole. Does it divide by 2? It ends in 0, 2, 4, 6, or 8. If it's 5. It ends in 5 or 0. 10 ends in 0. And 3 is one you can often do in your head. Like 27, you may not immediately remember it's 9 times 3. But like 2 plus 7 equals 9, and that's divisible by 3. So that means that's divisible by 3. It's a weird one. Yeah,
The thing with 27 is I instantly knew it was by 9. Because of how 9 works. Cause
yeah, the numbers add to 9.
well, it's cause it's always gonna be one lower and then one higher.
Uh-huh.
So it'd be 9.
As you
and
go
then
down
8, and a
along
1,
this, yeah,
and a 7, then 2. And 6, and a 3.
right.
That's all.
Let's do another one. Cause you weren't challenged enough. What do we wanna do here? Let's do 35 over 12. Times 20 over 42. Wow. Turning on the bottom, you didn't change shit. I think you're gonna get 25 over 18, but. Let me break this down. What's the 35 break down into? 5 and 7, right? What about 12? 6 and 2, okay. Okay. What about 20? 2 and 10? Okay. 42. I guess you're gonna see some shit like 2 times 21. 7 times 6, I hope.
Yeah, 6.
Okay. Most people do, when they do 20, they do 4 times 5, it's on the times table. But I guess 2 times 10 is 2. Alright, start crossing off in pairs, one from the top and one from the bottom. It's kind of easier when you've got a lot of them, just go across the top or go across the bottom, just go one at a time and look at the bottom. So I don't see a 5 on bottom, I see a 7 on bottom. I see a 2 on bottom. I don't see that 5, I see another 2 on bottom. So I'm left with 5 times 5 on top. I've got 3 times 2 times 3 on bottom. 25 over 18. When the top is smaller than the bottom. Seven. We call it a proper fraction. If the top is bigger. It's an improper fraction. Also. It's also larger than 1. So we can write improper fractions can be written as mixed numbers. And we'll do it with 25 over 18, so yeah. Well, the easiest way to do this is separate the top. Into chunks of the bottom that equal the bottom and then whatever's left over. This is 18 plus. If you're not sure, just do a quick subtraction. You get 7 left over, 18 plus 7. And we saw when we added fractions, we put them together. If they have a common denominator, we can actually pull them apart. This is 18 over 18 plus 7 over 18. And the 18 over 18 is a 1. And we generally write mixed numbers without putting a plus sign between them. And it doesn't have to just be increments of 1. Let's say we had 55 over 13. Earlier, we talked about how 52 was divisible by 13. So 55 is 52 plus 3. Break this up. And we get 4 for 52 over 13 and then 3/13. Now. If you get this. A number like a mixed number in statistics, it means you probably did something wrong. In stats, this normally indicates something wrong. Made a boo-boo. Because probability. As we'll see when we do chapter 5. Is always between. 0 and 1. So if you have a number larger than 1. It can't be a probability. And that's what a lot of stats is, it's like a probability or proportion of the whole. Any questions? I swear there's some calc students that would benefit from this. It's easy to forget how fractions work, and yet we use them a lot. Does anyone need that longer? Okay. Division of fractions. How can I divide 3 divided by 1/2? Or 3 over 1/2? Close, very close. I'm gonna pictorially show what's going on here first. Like. Let's say we've got 3 plates of Alfredo, chicken Alfredo. Better have chicken Alfredo, if I just say 3 plates of Alfredo, it sounds a little sick.
That's your second time where we see categories.
Right? And we're like going, okay, so division is repeated subtraction. Which I don't think anyone explained to me until I was like becoming a teacher. Which is weird. Like, how do you explain division to somebody? It's like, how many times can I subtract 1/2? So if I break up my plates of chicken Alfredo into halves. I've got a 1/2 a plate here, a 1/2 a plate there. And I'll number them. 3, 4, 5, and 6. So 3 divided by 1/2 is 6. And conveniently, so is 3 times 2. So. Division. Is just. Multiplication. By the reciprocal, it's called. And the reciprocal is the fraction flipped over. Four over 7 turns into 7 over 4. 1/9 turns into 9/1, which is 9. And if you add a whole number, like. 3 turns into, 3 is the same thing as 3/1, so when we flip it, it'd be 1/3. That's how reciprocals work. So you can always turn division into multiplication by the reciprocal. What number did I just give you a little bit of a while ago that was challenging? We did 35/12. We did that times 20/42. Why don't we give it to you as 42/20? Nope. We'll make you divide it as well. Change it to division, same problem we had before, now we use division, it's gonna change your answer. But you've already factored it, if you look at your old, what your problem did a little while ago. Yeah. We're still working on some of them. Finish up. Alright. I'm gonna write out 35 over the 12 first. And the 12. This gets flipped into multiplying by 42 over 20. So 42 was 7 times 6. 20 is 4 times 5. And what cancels out here? Go across the top, 7 doesn't cancel, 5 cancels. That 7 doesn't cancel. This 2 can cancel with that one. This 3 can cancel those. I'm left with 7 times 7 on top. 2 times 2 times 2 on bottom. So 49 over 8. Another way to write this that we'll talk about in the next week or so. This is 7 to the second power over 2 to the third power. We will do exponents next week. That's another way of doing it. I think we got a good stopping point. Not too many minutes left of class. If I continue, I'm gonna have to stop something midway that I don't want to stop midway. Better to do it all at once. Any quick, yeah. Why would I not? I actively encourage you guys to study together. Please study together. If you find people in here that are willing to study with you, it's good to make them now, make a study group now. Because you're gonna have to do a group project later on, and if you already have people you know and like. They make great people to do projects with.